Okay, we're going to be looking at calculating the spoil, concrete and bricks in this activity. There's only one new thing going to be added. We're going to be looking at blob footings. Now, blob footings are associated with our isolated piers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 isolated piers. Now those isolated piers have to sit on a footing. They can't just sit on the ground. And the footing goes off our dimensions here. So we've got our strip footing that goes all the way round as being 310 wide. So our blob footing is going to have a square base, 310 by 310, and the depth is 340. That 340 comes off here. So when we look at getting the volume of the blob, we do length times width times depth times the number of isolated piers. So in this case it's 11. When we do the spoil, we're going to be doing it from ground level down. So we're looking at 120 and 340. Okay, so that's going to give us 460 for the spoil. So when I look at this example, it's combining everything we've done before and just adding the blobs. So it's going to ask us to get the volume of spoil to be excavated for the strip and blob footings. Spoil has a bulking factor of 18%. Now we have to do the X factor first because this is doing a strip footing off our brickwork plan. So we go back to our rule for X factor, and it's going to be the width of the footing minus the 230 up here for the bricks, and that gives us 80, and we divide it by 2 will give us 40. So we have to add that to the dimensions of our brickwork. So if we just come over the page, we're going to have our new dimensions here. So if I have my length of the wall was 5.17 plus 5.08, and then I'm going to add my X factor of 40 and 40. I'm going to get a new figure of 10.25 for A. I'm coming to B, and when I added my sides up originally, it was 3.5 and 4.1, and then I'm going to add my 80, so I'm getting 7.68. Come round to C, we're adding our 80. It was originally 5 and we're adding 80. D doesn't change, so 4.1 stayed as 4.1. E doesn't change, 5.17, and we just add the 80 on here. So now, once we've got our new footing plan, we can do our intos and overs, and we're minusing the width of the footing. Now we're going down, and when we look here on D and E, we're not taking anything off. I tend to just put a 0 there, and we work out our length of our footing. Then we do our normal volume, length times the width of the footing times the depth, that's from ground level down. We get our normal volume. Now this is where we're going to add our spoil for the blobs. This part is new. So length times width times depth by the number of blobs. So we have the width of the footing is 0.10, so we times 0.31 times 0.31, then that's our depth, 0.46, the same as here. Then we have 11 isolated piers is what we calculated. So we've got that figure there. Now we're going to add these two figures here together, but we haven't finished. We have to add our bulking factor, and we're going to get a bulking factor of 6.399. Now, question B in the question, it says cost of removing the spoil at $40 a metre cubed or part thereof. Now this part thereof is a fancy way to say round up to the next whole number. I don't know why it's not written like that. So we've got 6.399. We're going to round up to 7. So 40 times 7, our spoil removal is going to be $280. Now we can go to our concrete. So our concrete, we have our length of our footing from here. So it stays the same. The width stays the same, it's just the depth is different. Our depth is 340. So we get this volume here. Now we add the volume of the concrete blob footings. Length times width times depth times the number of blobs. So the length is still the same in our spoil. The width is still the same. It's just the depth that has changed. Same as there. And times 11. So we're going to get that figure there and add it together. Now we need to go over the page, so I'm just going to move this and my page is ready. So we're going to do the total concrete is adding those two figures together and we get that figure. Still haven't finished, we need our 7% waste. So I'm going to times that figure by 1.07. We get our volume order, volume is that, and then we have to round up in increments of 0.2, so our concrete order is going to be 4.4. Now, when we look at the cost of, the cost of the bricks, the cost of the concrete, it's going to be 155, so we just times 155 times 4.4. Right, so that's my answer there. Now, when we do the bricks, the big thing to remember is you go back to your brick wall plan. You don't use the footing plan. The footing plan is only used for spoil and concrete. So we use our footing plan, the original plan, and we have to do our intos and overs. And remember, we're doing bricks, so we need to take off the width of a brick. But when we come down to D and E, again, they are the internal corners. We don't take anything off. And we're going to get a length of the brickwork is 35.1. Now remember, we need to get the area of the wall, so we're going to go length times the height. So the height will be in the question. So in question E, the height is 516 millimeters. So I'm going to have 35.1 times 0.516. That's going to give me my area. So now we have to work out our bricks. So we got area times 50 times the number of skins. Now our area is there times the 50. Now the skins, we know it's only one skin because it's going to be, we've taken off 110. We've assumed that, it hasn't said it in the question actually. So that's how many bricks we have for our wall. Now we have to work out our courses. How many courses? So the formula or rule is the wall height divided by 86. Why 86? The height of a brick is 76 plus 10 millimeters of water, so 86. So we've got 6 courses. So now we're going to work out our engaged piers and our isolated piers. So our engaged piers is number of courses times the number of engaged piers. So I've got 6 times 23. Where did I get 23 from? I go back to my drawing and all I do is count around the outside on the wall. That's my engaged piers. So I've got 23. So 6 times 23, 138 bricks. When I'm doing my isolated piers, I do number of courses times the number of isolated piers times 2, because you always have 2 lots of bricks on an isolated pier. Always 2 lots. So we have 6 courses. We have 11 isolated piers. We worked that out before. Times 2, so 132 bricks. So we've got that many bricks and that many bricks. So we're going to add all our bricks up. The wall engaged piers and isolated piers, we get that many bricks altogether. Now we're going to add 10% in the question wastage. So in total it's 1,294 bricks. Now the cost for the bricks for question F, it says it's $680 per 1,000 bricks. So we're going to make this is more than 1,000 but less than 2,000. So I'm going to divide that by 1,000 and that will give me, oh sorry.
So with the waste one, yeah.
Sorry.
Yeah.
Come here. Sorry. So divide that by 1,000 and that'll give me 1.294, and that's going to give me my answer of $879.92. So you're just making this part here out of 1,000. Okay, thank you.